Hi everyone, welcome, and thank you very much for attending this session. Today we're going to talk about how to use Unreal Engine in simulation applications. My name is Sebastien Loze. I'm the industry manager for simulation here at Epic Games, and let's start and dive directly into this presentation. So today, as discussed, we will talk about simulation, and here in the crowd, we noticed that there's a lot of growing interest around Unreal Engine and how to apply Unreal to your simulation context. It's a very large world, and it's a world in which we can easily recognize ourselves as the simulation experts. You probably have seen this picture before. You know, at the end of the day, what we're achieving is solving real-life puzzles using computers to make sure that we understand the world better and that we're more prepared so that we can to what can happen to this world. Either it is to train a machine or train a human, the goal is always the same here. And Unreal in this context is a game engine, and some people sometimes get confused when we talk about game engines. What's important to notice, and because I'm French, I'm using definitions to define English words when they're very complex. What we can really realize here is that a game engine is actually a development platform. It is way more than the renderer, the rendering engine, and the beautiful pixels that are the tip of the iceberg that people notice when they look at Unreal. Behind the scene, there's a large number of modules and capabilities that allows you and your peers to develop applications and to build software that are built to unite what is sometimes very tricky to regroup real-time, accuracy, and visual realism. And we'll see a couple of elements that can help you in this process. When I started in the simulation field 20-ish years ago, it was very, very evident that there were two separate tracks, two separate worlds, the worlds of video games and the world of simulation. While both of them were sharing the same value of being engaging, multiplayer, connected, they had very big differences when it came to physics and visual realism. The video game was more focusing on visual appeal, and the simulation world was focusing on the physics realism. Now we're seeing and we're observing that this difference disappeared. The only remaining difference in between these two worlds is the goal. One is meant to entertain people. The other one is meant to learn about things that doesn't exist already, or to learn how to be better at doing something that is sometimes too complex, too expensive, too dangerous to do in real life. So how did it all started on the Unreal side of things with respect to simulation? Well, it didn't start with us, actually. It started with you, with people in the field starting to use Unreal in the simulation domain without us helping. And it was amazing for us to realize that, while with very limited and reactive support from Epic Games long time ago, these teams of innovators and early adopters built fantastic training environment, which over the last years have been supporting men and women in the forces and other departments, including transportation, homeland security, and healthcare. One remarkable thing about this application is that they all inherit from the gaming tradition narration. We realized that using the framework, the early adopters were able to leverage very gamey process of training and apply it to the virtual curriculum delivery mechanism they were building. And in the last years, the idea matured at Epic Games. We're already with Unreal Engine building a lot of things that were usable for the simulation field. But we need to be more proactive in this domain. And this willingness came from these observations. And not only our observations, we're not the only ones saying that, but we started to see game engine being pushed and supported by our leaders when it comes to innovate and to support digitalization of training. We are clearly, since a couple of years now, entering the second phase of virtual training digitalization. And that's where we started to see more recently new use cases. On top of getting more and more of simulation users, we started to take care of several simulation software architecture challenges we had to find solutions to. And these are the first steps. In this context, you start to see a lot more of different use cases where the simulationists out there are using Unreal in a context that is now very far from the gaming world and getting closer to the traditional simulation world, while bringing the layer of visual realism that was not present traditionally in that field. So it is a large field for us. It is a very important field for Epic. And it goes from healthcare to space exploration, passing by civil aviation, construction, robotics development, fast responders, and defense. These fields are all very different, as you can see, and that's also a very large set of use cases within each field. When you look globally at the simulation applications workflow, it goes through three main steps. You create or distribute some content, you execute some scenarios, some test, some analysis, and then you regroup and you do after action review or simulation result collection. So in these three main steps, in all these three steps, you see specific use cases where a game engine can become super useful. And because the field is so large, because the scale of application is so large, for us it is very important to remind everyone that Unreal is just a platform, just a development platform. And this is what we want to remind here. The framework level. This is where Unreal will be beneficial for all your developments in the simulation field. It's at the same layer, at the same level as your standard database, your interoperability tools. That's where you can find your game engine, at the framework level. On top of that, based on your expertise, based on your subject matter expertise and your integration skills, you will build the specialty features and implement the specialty features that you need and implement the curriculum definition that you need on top of that. And in that structure, in this very simple and pragmatic structure, you will create any type of simulators and any type of experiences based on the same framework that you can leverage and reuse as a training environment, as a global training environment or a global framework that can be reused from one project to the next without having to reinvent the wheel and the low level that is already provided by this game engine. So a couple of things have been done in the last years, and I want to restate some of these fantastic improvements to the pipeline that we made to make sure that your life is easier. First thing is, how do I integrate my content? How do I integrate my files into this new environment? How do I make sure that everything can get loaded, that I have already can get loaded into this Unreal context? And that's the DataSmith API. You heard about it in other sessions. You can read about that more in detail in our documentation. The value of DataSmith in the simulation context is to make sure that you take this very well-defined, very accurate, and very precise data set that you have of representation of all the objects you want to simulate or to manipulate in your experiences. And you can not only load them, but also dynamically optimize them to make them accessible in real time. It allows you to take these gigantic files and simplify them and create an automated pipeline to optimize these files and to bring them to the real life experience, the real time experience that you're building with Unreal. And starting from scratch sometimes can be really puzzling, can be really scaring. Not everybody have a team of artists that they can rely on. Not everybody have the source data or the CAD models of the type of vehicles or the type of systems that they want to simulate, and it can be really scary. So the marketplace is a very good source for your research and for finding the right content for your application. We are also working with third-party experts who built over the years libraries of content and who are able to distribute this content into the Unreal environment natively now. So that is a very interesting point, the fact that you're not by yourself, you're not having to recreate everything from scratch, and that the content of all the type of systems that you need to simulate is already out there and already waiting for you to be used. Now, the content, the actual vehicles and systems that you want to simulate is one thing, but you want to go larger than that. You want to be able to deal with large virtual environments. And large virtual environments can be quite puzzling. There are already a lot of tools into Unreal natively to help you build geotypical environment, to build your landscape, to leverage your terrain splines and make sure that you have all the right tools to modify the structure of a specific terrain as you see fit. But in some cases, you need to make a choice. Do you want to use geotypical information? Do you want to use geospecific information? And how do you get your GEOInt data into Unreal? That was puzzling a couple of years ago, and we changed it. And because it's hard for us to decide for you, it's very hard for us to decide on behalf of the community. And we want to make sure that people understand that we want to make sure that we provide an approach that is very inclusive. So we don't want to make you select. We don't want to make you. We don't want to select for you. We don't want to take choices for you, and we want to help you to use the pipelines that you prefer, and to, instead of deciding this is the best pipeline, to allow you to use the pipeline that you always used. And that's why we built in the last years this ecosystem of partnerships with several players of the industry who have this incredible expertise of building virtual environment based out of GIS information. And we work with Trend Graphics, we work with Esri, we work with Presages and others to make sure that no matter what your pipeline is, you can use the tools that you always used and integrate all this GIS information, all this GEOInt information into Unreal. In some cases, again, you don't want to create these databases because you already have them. If you already have them, then through Datasmith, you can start integrating some elements of your existing database or your specific format or owned format of database into Unreal. But in some cases, you're using standards, and in many cases, you're using standards. And we get very close to the CISO, the OGC, the USGIF groups to make sure that we don't reinvent standards and we are using the ones that are out there. And to simplify your life, this is where we're going. In the coming year, you will start to see more plugins for very large terrains for Unreal Engine. Some work is being done at Esri. The ArcGIS team already presented this beta version of this plugin for Unreal to absorb the ArcGIS content. There are work being done at Presages to make sure that CDB is supported in their orb viewer. Some other players of the industry, of the simulation industry, are working on CDB runtime publishers for Unreal. In parallel of that, companies like Cesium, the owners of the 3D tile open format, are building a plugin that will be an open source plugin, which will be delivered at the end of summer 2020. And this open source free plugin will allow 3D tiles and all the cesium ion database to be read into Unreal. So as you can see, we started from being, reacting to the industry needs to becoming more proactive to it. And that's what we will see more and more coming from Unreal Engine. In terms of deployment now, it can be tricky and can be puzzling to start your project and your program knowing already what HMD you will use moving forward in your application. With the OpenXR approach and supporting OpenXR, we want to make sure that no matter what your HMD is, as long as it's supporting properly OpenXR, you're supported in Unreal Engine directly, and you can leverage this capability to not having to make a choice from the get-go, but work on your program, work on your project, and as you get to the deployment phase, then select what you want to deploy on. And simulation is a bit special when it comes to deployment. We have needs in our field that are very special needs that are related to formats or type of deployments that you don't see very often. Sometimes we need larger environments. Sometimes we need the bigger picture. And with some partners that we developed this capacity called NDisplay. NDisplay is a module that is part of Unreal Engine. And by making sure that we can read the config files from our different partners, we allow users to build multi-display configurations that can be either on a flat wall, but also on a curved display, and allowing everybody to build a dome configuration without having to be a specialist of that. And that makes things way simpler. It allows also to accelerate deployment and to make sure that configuration and management of complex deployments is becoming easy. I talked a little bit about standards earlier, and one thing that's also super important are the communication standards in the simulation domain. One key element of that is the DIS and HLA integration. There are other formats that we're looking into, other communication modules that we're looking into, including DDS and others. The HLA and DIS support that's provided by DS Tools today and could be created by others. I mean, the API of Unreal and the source code of Unreal being open and being accessible to everybody allows everyone to build their own integration. But we want to make sure that no matter what integration is needed, if you're using a standard, you can find a solution in the ecosystem of our partners already. A last point about deployment and distribution of simulation. There is a large number of modules that are extremely important when you're building a deployed solution. One of the core elements that we developed and released more than a year ago now, in November 2018, is pixel streaming. Pixel streaming allows you to use the GPU, the online GPU capabilities, and directly leverage that into your system. So you don't need to have local super performant GPU or super performant machines. We recognize that in the simulation context, the IT limitations sometimes are making it hard to have access to the best hardware possible. So using online capabilities, using online hardware capacities is extremely important, and cloud-based solutions are extremely important. So the integration with AWS, Google Cloud, Azure, the early integration with Stadia last year, are allowing our users to build solutions that can be easily deployed. A good example is shown here with what GM is doing with the Cruise running on Google Cloud, with having like 300,000 of instances of Unreal running to create the virtual environment for these vehicles. The other key concept that we see trending in the training and simulation world is the modeling and simulation as a service. While it started with CISO and with some research from the NMSG, the NATO modeling and simulation groups, we started to see more and more requests in other domains as well for simulators that are available online, always on and always ready to be used by trainees anywhere in the world. The example you see there on that slide is from the ITT, which is the new training environment built by the NATO COE, the Center of Expertise for Modeling and Simulation in Italy, in partnership with ACT, the Allied Command Transformation from NATO in Norfolk. This has been developed in Unreal in less than 6 months. And that's a very good first step in the direction of building solutions that are available when you need it, where you need it. The last point about integration and about what we built in the last years in the simulation domain. When you want to build a simulator, there's a big change, big evolution that you can see in the last years is going away from the monolithic approach of building solutions. There's not a company today that will come to you and will say, hey, look, that's my simulator. It's built entirely by us. We didn't play with others. We didn't integrate any other thing. And that's our monolithic black box. You won't see that anymore. Now, more and more, you see structures which are heterogeneous, where you have different parts using the best modules from the best providers based on their expertise. And we recognize that when you want the best precision possible, when you want the best accuracy possible in the simulation behaviors of a model, you need to work with the experts of this field. On this slide, you see only a couple of the examples. There are more coming. There are more being developed. Namely, I can mention the company Algorix and many others that are building these modules to simplify integration with Unreal. These plugins are available. They're out there. They're meant for you to not having to work on the integration, but to work on your expertise, to work on the curriculum, and to work on making sure that the data that you inject into these solutions are the best ones. The integration we already took care of. So this is just the beginning. As I said, it's been more than 2 years that we actively are developing new capacity in the simulation domains with Unreal Engine. There is a lot more coming up. You heard about Unreal Engine 5. UE5 is coming next year. Larger terrains, volumetric clouds. We're working also with some partners on non-visible domain capacity to bring more sensors capacity into Unreal, more communication standards. So at this point of this presentation, what I'd like to do is to transform that into a discussion with you. So you're all online. You will see in a minute our Q&A starting, and we'll be able to make this little presentation into a little discussion. And we'd like to hear from you. We'd like to know what you need. We'd like to know what are the pain points you're facing currently in the simulation domain that you think or hope that Unreal Engine can solve. And to give us these guidelines is helping us to grow this roadmap into making sure that Unreal Engine becomes the best tool possible to help you to become the foundation of the frameworks on which you build your simulators. With that, I'll thank you, and I'll see you in a minute in our Q&A session. Thank you very much.